All right, back at it right away. Section 851, adding and subtracting rational expressions. So at 8.4, it was just multiplication and division, essentially of fractions. It does get a little bit more, a little bit dicier, because when we add or subtract fractions, we need a common denominator. So we'll get into that. As a quick little warm up, we're going to do one of those division problems. This is x squared minus 16. Again, my first step almost all the time is going to be to factor. Here's x plus 5. And then I'm dividing by x plus 4 times x plus 4 is how that top one factors over x plus 5 and x minus 2. Okay. Again, now I'm going to make a running list of what x cannot be. So x can't be negative 5 or positive 2 currently. But again, because it's division, I do need to take the, I'm going to take the second fraction, flip it, and change the problem to a multiplication problem. So it's going to change to times x plus 5 times x minus 2 over x plus 4 times x plus 4, which adds, because x plus 4 has gone to the denominator, that adds negative 4 to my list of numbers that I can't have in the domain. And then from here, I'm just going to cancel. So I see x plus 5 and x plus 5, x plus 4 cancels x plus 4. And then I'm left with, that's all I have left. So I got x minus 4 times x minus 2 all over x plus 4. And that is my end result. So factor, talk about domain, flip, talk about domain again, and then just cancel stuff out. Okay, so just to kind of recap, when you are adding fractions, right, we need a common denominator. The calculator will actually do this for us, but we're going to have to go back to adding by hand here. So I need 3 and 4. I need these denominators to be the same number. So my thought is, what do 3 and 4 both go into? What number are 3 and 4 both a factor of? And that's 12. So if I know I can get the bottoms to both be 12, then that allows me to add the numerators. So I'm going to go ahead and multiply this second fraction by 3 and the first fraction by 4. Don't know why I went in that order, but whatever. So 1/3 becomes 4/12 and 3/4 becomes 9/12. Then to add those fractions together, I simply add 4 and 9 and I get 13/12, and we leave it like that. La-di-da, we're done. What we're going to be getting into is what happens if there's a variable involved. So 3 over x minus 6 over 5. Maybe a little bit trickier to see where we're going with this. But in order to change a fraction, I have to use multiplication. So my only option is to get 5 times x as the common denominator. So in this second fraction, I'm going to multiply by x on top and bottom. And in the first fraction, I'm going to multiply by 5 on top and bottom. Again, just so that's what I need to achieve my desired denominator of 5x. So this is 5 times 3 is 15. And then the second numerator is 6 times x, so that's 6x. Okay. And then I am going to here take 15 minus 6x all over 5x. Now, after you've added or subtracted, we check to see, can I simplify? And in order to know if you can simplify, that does require us to factor. I see the numerator, the 15 minus 6x, has a GCF of 3. So I'm going to write it as 3 times 5 minus 2x over 5x. Again, don't go crazy. Don't be thinking that x cancels that x or that 5 cancels that 5. The only way to cancel this thing is to see another 5 minus 2x. It's got to be the whole parentheses. I don't see it there. Now, what could happen is if these were both 5s, then those 5s could cancel out because that was factored. That 3 was factored out of the top. As it is, 5 and 3 have nothing in common. So this is our final answer. And because nothing canceled, you could leave it like this as well. But I would just encourage you to factor if you can, just to always check at the end there. Again, and if the last thing, if you wanted to talk about domain, right, we could say x cannot be 0 because that is my common denominator right there. So that's kind of the picture of what we're going to do to add and subtract these things. You'll see it picks up a little bit in difficulty. So here, in order to, I have 1 over x minus 3 and 6x over x plus 5. I want these denominators to be the same. What I cannot do is just add 8 to both sides. Right, if I added 8 to the bottom, it would become x plus 5, but that's not mathematically legal, and this is not a proof. But if you take the fraction 1/2 and you add 5 to both the top and the bottom, I would then have 6 over 7, and clearly 6 out of 7 is not the same as 1 out of 2. So adding to both sides of a fraction is not agreeable, not a mathematical legal thing to do. So what I'm going to do here is, this is kind of like in like balancing chemical equations. You're just going to introduce things to each fraction until they look the same. So this first fraction, the way I think of it is like, what does this fraction not have that this fraction does? Well, the second fraction has x plus 5, and I don't see x plus 5 in the first fraction at all. So I know I'm going to multiply this by x plus 5. Okay, if I do that, anything I do to the denominator, I need to also do to the numerator. Okay, that's great. Now, this denominator is both x plus 5 and x minus 3. Do my denominators match? And clearly they don't, because all I have over here is x plus 5. Well, that's fine. All I'm missing is the x minus 3. So I'm going to multiply x minus 3 to top and bottom. And now we see that, hey, look at that. Even though they're not written in the same order, I do have identical denominators, or they are written in the same order. I have identical denominators for both the fractions. So now I can add the tops together. Okay. And in order to do that, I'm going to write, now I'm not going to refoil that denominator. I'm going to keep it x plus 5 times x minus 3. For both of these things, x plus 5 times x minus 3. Okay. I do have to multiply or distribute up top here. So I'm going to x plus 5 multiplied by 1. I'm going to distribute that, which is just x plus 5. And then here I'm going to distribute the 6x. That would give me 6x squared minus 18x. And now from here, since I have a common denominator, I can add the tops together, which means I'm going to combine like terms. Again, I want to kind of go in order from least to greatest. I see 6x squared here. So that's going to go first because that's the only x squared that I have. I have positive 1 minus 18x, so that's minus 17x. And then I have that plus 5 at the end, all over x plus 5 times x minus 3. Now, just when you think you're done, and that is like this fraction is fully added, but I think it can be simplified because I think the top can factor. Again, the bottom's already factored. But if I look at the numerator here, I see 6, 17, and 5 don't have a common denominator, but I can find numbers that multiply to positive 30 and add to negative 17, and those are negative 15 and negative 2. So what I'm going to do is I'm going to take 6x squared, replace the middle term with minus 15x and minus 2x. Okay, and then there I'm splitting right down the middle. And now we factor by grouping. So I have 3x that I can take out of the first set from 6x squared minus 15x. Nope. That is 2x minus 5. And over here, I see I'm starting with a negative. So I'm going to take out negative 1. Ooh, not line. Take out negative 1, and then I have 2x minus 5. Okay, which means my fully factored version is 3x minus 1 times 2x minus 5. And some of you may see that this was a kind of a giant waste of time because nothing cancels when I factor the top. Here I've got x plus 5 times x minus 3. Clearly there's no cancellation there. There's no identical factors. So this is our final answer as long as x does not equal negative 5 or positive 3, because again, I cannot divide by 0. So technically at this point, this would be an acceptable final answer. But if it can factor, you want to factor it just to double check and make sure that nothing cancels out. So, all right, moving on. Same sort of thing. We're adding those rational expressions together. If your denominators aren't factored, we want to first factor them. So this is 3 over 4x minus 8 isn't quadratic, meaning it doesn't contain x squared. So all I could do is look for a GCF. And sure enough, I have a GCF of 4. And then here, x squared minus 4 factors into x plus 2 and x minus 2. Okay, so again, I'm looking at this thing trying to figure out how can I get their denominators to match. So I see that the right fraction has an x plus 2 that the left fraction does not. So that means I'm going to have to multiply by x plus 2. Now I know it's not right next to it. I didn't leave a whole lot of space for myself there, which is great. So now the first fraction has everything that the right-hand fraction does, but over here, I'm missing this 4 that the first fraction has. So I'm going to multiply by 4 on the top and the bottom. Okay. And now, if you want to, you can go ahead and multiply the numerator or distribute the numerator right away, because that'll make our life a little bit quicker, save some time and space. So 3 times x plus 2 becomes 3x plus 6, and then 5 times 4 is just 20. Okay. It's at this point that you could talk about domain restriction if you want. I'm going to wait on it. Don't have a real good reason as to why. Now I'm going to add these numerators together. I see that the 6 and the 20 are like terms, so 3x plus 26 all over 4 times x minus 2 and x plus 2. Order doesn't matter with the factors. You can put the x minus 2 first or the x plus 2 first. That doesn't mean anything. Again, here, 3x plus 26, there's no GCF. It's not x squared, so I can't do anything with that. So this is my final answer as long as x is not positive 2 or negative 2. So get a common denominator, add the numerators together, and then try to factor or simplify. Okay. Subtracting is almost the exact same thing, but if you're going to make a silly mistake, this is where it happens. Again, factor. If you can factor this stuff, we're going to factor it. So here I got x plus 2 over x plus 3 times x minus 2. Okay. Again, my quest now is to get a common denominator. So I see x plus 3 that the left fraction doesn't have. So I'm going to do that to both sides. And then over here now, the left-hand fraction has 3 factors, where the right-hand fraction only has 2, so something's missing. And over here, I'm going to multiply by x plus 2 on top and bottom. Oh, look at that. That's nice. So now I have that same denominator for the whole thing. So I'm going to go ahead and distribute the top. Since this is x plus 3 times x plus 3, I do need to FOIL or fully distribute. Don't just call it x squared plus 9. This ends up being x squared plus 6x plus 9 on the top over this big long denominator. And then here I'm subtracting x squared plus 4x plus 4 all over that same freaking denominator. X plus 2 times x minus 2. All right. So great, fantastic. We have a common denominator. Now, this is where you will make the silly mistake. Please don't try to, do your best to understand that this subtraction symbol has to go to the entire second numerator, which means I have to basically distribute that negative sign. So I need to apply that negative to all three of these terms. They were all positive, which means they now are all negative. Okay. So I essentially have x squared plus 6x plus 9, which was the original, or that was the first fraction, minus x squared minus 4x and minus 4 on top. Okay. If I do that, I see x squared minus x squared, so those will make 0. 6x minus 4x is 2x. 9 minus 4 is positive 5. So that is my fully simplified numerator. That's what happens when I combine this with that. Again, because I distributed that minus sign. So then I'm just going to write this with my final denominator of x plus 3 times x plus 2 times x minus 2. And so my domain or my restrictions would be x can't be negative 3, positive 2, or negative 2. Oh my gosh. Okay. Kind of a long process. But we're going to take all that jazz, move this up. Okay, so common denominator, multiply or distribute the numerators, combine them, but the key here was, again, this part right here, where the subtraction had to go to all three terms. This is my final result, though. My final answer, right here with that domain restriction. Okay. Go ahead and pause it if you want to give this one a shot real quick. I got x over x minus 1, no factoring there. On the right side, I got 2x minus 1 over that factors into x minus 2 and x minus 1. Okay. So here I see that all I'm missing from the left side, I have the x minus 1. I just need the x minus 2, which is kind of nice because the right-hand fraction didn't need any additional stuff. So if I distribute that numerator, I get x squared minus 2x over my denominator of x minus 2 times x minus 1. And then plus 2x minus 1 over x minus 2 and x minus 1. This is kind of silly to write it as two separate fractions. I should have just combined the numerators together right away. But if now it is addition, right, so I don't need to distribute the minus sign, I have negative 2x and positive 2x. So there, those will cancel, and I'll get x squared minus 1 all over x minus 2 times x minus 1. I know that my restriction is x can't be 2 or 1. And now finally, this is the first time that it'll actually be useful. That top does factor. The x squared minus 1 does factor into x plus 1 times x minus 1, which is useful because then I can cancel out the x minus 1s. So my final answer would just be x plus 1 over x minus 2. So this is my final answer with this domain restriction. And again, even though even though the denominator is only x minus 2, there are still those two values of x that it cannot be. So, yeah, this is not going to work. Oh, that's nice. So there's where we end up. Okay. So yeah, give those problems a shot. Not a whole lot of homework for this for day one. Just get that common denominator and go from there. Stop recording. There we go.